Hi everyone, bonjour. IB Crocodile is here. Welcome to my YouTube channel. We provide supporting academic videos for both physics IB and math IB on both the standard level and high level curriculums. Today, I would like to share with you some basics or fundamentals of wave, right, which is very important in the IB physics curriculum for both standard level, of course, and the high level as well. Okay, so let us start with the definition of a wave. So what is a wave? A wave is a disturbance. The definition, the key word or the first word of any definition in physics is the most important word. So wave is a disturbance. Now, this disturbance here travels in a medium which can be vacuum in case of electromagnetic waves like light, right? And this disturbance here, or the wave itself, transfer energy and momentum. So wave transfers two things or two quantities, energy and momentum, from one place to another. Now, the direction of propagation of the wave, it is the same direction of the energy transfer, which makes sense, right? And then there is, okay, a little bit of motion, not large scale, a little bit of motion of the medium itself, you know, as the wave passes through it. I love this definition. This definition is, the source actually is Cambridge textbook, right? And it is very like complete definition. From here, I can actually classify waves, like one classification of waves. Waves can be mechanical waves or electromagnetic waves. So mechanical waves, waves that need a medium to propagate, okay? Like air, for example, water, any medium to propagate, okay? These are mechanical waves. But if the waves are, do not need a medium, like if the wave can pass through vacuum, so this is non-mechanical waves, and we call them electromagnetic waves. And of course, later we can talk in details about the electromagnetic spectrum, right, which includes the visible light and infrared radiation, ultraviolet radiation, gamma rays, and all of this sort of spectrum here. But the bottom line here, the first classification, waves can be mechanical or electromagnetic. Now, the second classification of waves can be transverse waves or longitudinal. Okay, so what is the definition of a transverse wave? So the transverse wave, where the direction of the wave itself is perpendicular to the direction of the vibrations of the medium itself. So now we agreed from the definition that there are two types of motion: the disturbance itself in the medium, and also the particles of the medium, you know, they will have a little bit, a low scale or a small scale motion, right? So now we have two types of motion: the particles in the medium and the disturbance itself. For example, let's have a look at this water waves here, right? So if someone of you throw like a rock or a small stone, you know, so you will propagate, or you will create, you know, this sort of disturbance, right? Now the disturbance itself is moving horizontally, right, left and right, while the medium itself, which is the water droplets, they move up and down. So the medium here, or direction of the motion of the medium, is perpendicular to the direction of the propagation of the wave, and hence this is called a transverse wave. Okay, now the second type of wave, this classification will be, according to the second classification, are longitudinal waves. Obviously the other way around, the opposite. So if the vibration of the medium are parallel or are in the same direction of the propagation, like this spring here, for example, right? So the spring itself vibrates like horizontally, and the disturbance also is propagating horizontally in the same direction. So this is called a longitudinal wave. Also, sound waves are are examples of longitudinal wave, right? Now the medium, so sound actually is a mechanical wave, sure. Why? Because sound needs a medium to propagate. But then sound also is a longitudinal wave. Why? Because the medium or the air particles will propagate or will vibrate in the same direction of the sound. And therefore, sound is longitudinal. Wave is an example of longitudinal wave. Okay? Now, longitudinal waves, they are formed of regions of compression, right, and region of rarefaction. Okay, the counterparts of these two definitions or two properties will be crest and trough for the transverse wave. Okay. Now, other examples here are seismic waves. You don't need to know too much about seismic waves, but you need to know a little bit about seismic waves. So look at here, this is an energy source, a truck, a source which will emit some sonic or some sound waves, right, propagating through different layers of the earth, right? And then there are some receivers, right? And these receivers here will receive at different distance and different timing and all of this. So it depends on the timing, of reaching these receivers, what petroleum engineers or geoscientists, would create or are able to create what we call seismic maps. And these seismic maps will be interpreted by a geologist or geoscientist to see the different topography, of the earth and the different layers or reservoirs or formations. And the seismic waves is the first step to find, or hopefully to find, a hydrocarbon trap. Okay. So anyway, so there are many types of seismic waves. There is something called a P wave and something called S wave, right? So the P wave is composed of expansions and compressions, or rarefactions and compressions. So obviously the P wave, a seismic P wave, is an example of longitudinal wave, while S wave is an example of a transverse wave, right? Because it is formed of crests and troughs. Okay, so this is basically the second classification of waves, right? Transverse waves or longitudinal waves. Now let's look at the wave diagram. Okay, so this wave diagram, okay, basically for a transverse wave, but it can also work for longitudinal wave, just by keeping in mind that the structure or the components or the composition of a longitudinal wave. So we have definitely a periodic motion, let's say a sine wave or sinusoidal function. It could be also cosine function, it doesn't matter, right? And then there is a equilibrium position, and then there is a maximum point here, which we call it the peak or the crest of the wave, and the minimum point is called the trough. Now the distance between the equilibrium position and the crest or the trough is called the amplitude. Okay, so the amplitude, by the way, the amplitude is always positive. The amplitude is always positive because we talk about the maximum distance, either to the crest or the trough. Okay. Now, what is the wavelength? Another definition, or this is fundamentals, again, basics of waves. Okay, so we know what is the amplitude of the wave, and sometimes we denote it by X naught in the textbooks, or A, capital A, amplitude, right? And then the wavelength, which is the shortest distance between 2 points that are in phase. right? So which means 2 consecutive crests or 2 consecutive troughs. Okay, because this point here, are in the same phase of that point here, because it came back to the same angle, right? Or this point here as a trough is, of course, in phase with the second or the next trough. So that's why we call 2 points are in phase, or the distance between them. So it's going to be the wavelength. The unit of wavelength in SI system is in meter. Unit of amplitude in SI system also is meter, because it is just a distance. Now, the next here is the period, the time period. What is the period? So by definition, the time period is the time taken to complete one full oscillation or one full cycle, right? So let's look here. We have, just a simple schematic here. So here we have like the time in seconds on the x-axis, right? And then we have like basically 3 cycles, right? Now the time taken to complete one cycle here, you may agree with me, okay, let's say 4 seconds, right? So the period of this wave here is 4 seconds, right? Which is the time taken to complete one full cycle, from the initial position back to the same position. So this is a cycle, a complete cycle or complete oscillation. Okay. Obviously, the time period, it takes a capital T as a symbol, and again, unit of time in physics, or in SI system, is going to be seconds, not microseconds, not milliseconds. It is seconds. Now, the next is the frequency. Now, what is frequency by definition? Frequency by definition is the number of complete cycles per unit time, or basically per 1 second. So the frequency is the reciprocal of the time period. If you know the time period, you just flip it and get the frequency, right? So by definition, again, the frequency is the number of complete cycles, represents the number of complete cycles per unit time. But here we strictly use SI system, so I would say per second, right? So let's see here, for example, like we have here, okay, a total of 24 seconds, right? And we have like, okay, 1, 2, and 3 complete cycles, right? So the time taken to complete one cycle is going to be 24 divided by 3, which is 8 seconds, right? So you flip that, so you get the frequency, right, which is 1/8, right? So because here we have 3/24, right? So basically 3/24 or 1/8. So the number of complete cycles per second. So basically, the easiest way is just to get the time period and just flip it to get the frequency. Okay. So the frequency here is going to be 1/t. So, and the unit of frequency 1/second, or second minus 1 to the power of -1, and we call this hertz, Hz, hertz. So hertz is second minus 1, or the unit of frequency in this case. Okay, so this is just a quick overview. We learned the definition of a wave, a complete definition. We know the 2 classifications of waves, mechanical or electromagnetic, and the second classification, transverse or longitudinal, right? And then we talked about important definitions of wave, like amplitude, wavelength, period, and frequency. By this, I conclude my video for today, and thanks for watching. If you feel like this channel is important to you or helpful to you, you may consider to subscribe. Thanks again for watching, and have a good day.